Hey, welcome to another McCainFourth.com math video. Today we are looking at identifying multiples for OA4 practice test. Your test is going to be tomorrow, so I'm glad you're here watching this video to help you practice and check your work. Couple of reminders here at the top. Have your math notebook out while you work on this practice test to look at the examples we did in class. After you finish the paper, or while you're working on it, go to McCainFourth.com, which you already did, to watch the YouTube video. If you don't have internet access at home, when you get to school tomorrow, you can check the website on your iPad and check your work, so make sure you do that. And also, as always, look for the secret word and write it below to get some bonus money that will be revealed somewhere, and you will find it out. All right, here we go. Number 1 says, what are the first 5 multiples of the number 7? So I'm going to underline multiples. Multiples are counting by the number. Circle the number 7. I know when I'm finding multiples, I always start at counting at the circled number. So I'm going to start with 7. That's going to be the first multiple. Then I have to count by 7s. So 7, I know after 7 is going to be 14. Then I have to add 7 more to get 21. I can do this in my head or use my fingers to help me add, or I can use my calculator. So once I have 21, I can do 21 plus 7 will get me my next multiple. That's 28. And then I can add 7 more, either in my head with my fingers or on my calculator. Add 7 more to get 35. And there you have it, the first 5 multiples of 7. Moving on to the next part, directions. Show the division equation used to determine your answer, then circle yes or no. So number 2, is 63 a multiple, multiples are, counting by the number, of 7? So here I need to ask myself, how many times can I count by 7 to hopefully get 63? And I see that I have a missing multiplication problem here. And I know when I have missing multiplication, I can use the inverse or division to test it out and see what my answer is. So there's a spot here for my division equation. So I'm gonna put 63, my total, divided by 7 equals, maybe I know the answer, or I can use my calculator and put in 63 divided by 7 equals 9. 9 is a whole number, there's no decimals, so I know that yes, 63 is a multiple of 7. Number 3, is 67 a multiple of, multiples are, counting by the number, 6. Go ahead and circle 6. Then I need to ask myself, how many times can I count by 6 to hopefully get to 67? I can do the inverse operation of division to test that out. 63 divided by 6 equals, grab my calculator, plug it in, 67 divided by 6 equals, and I get this number 11.166666667. So I just want to round to the hundredths, my first 2 decimal points. So I'm going to put 11.16 and end it there. And I can see that this is not a whole number because I have decimals. So the answer is no, 67 is not a multiple of 6. Moving on to the next part. The directions say, circle the correct answer and write the division equation, or underline the last digit to show your work. Think, strategy, or trick. So when we look at these problems, we want to think, do I know a trick that can help me solve this quickly just by looking at the last digit, or am I going to have to use a strategy and use my calculator to solve? So let's look at number 4. Which number below is a multiple, multiples are, counting by the number, of 3? Now I don't have any tricks for 3, so I'm going to have to use a strategy. And to use a strategy, I need to think, how many times can I count by 3 to hopefully get, and then a blank for all of these choices. And I know I have to test them all out before I choose my answer. So I can see that I have a missing multiplication problem, so I can do the inverse division to help me solve. So 142, I can just say divided by 3 equals, grab my calculator, 142 divided by 3 equals, and I get 47.33 because I'm going to round to the hundredths. And I'm going to put that here, 47.33. Now I see that this is not a whole number, so I'm guessing my answer isn't going to be A, but I have to check every single choice to make sure I didn't make any mistakes anywhere. So next I have 180. I can divide that by 3. Use my calculator. 180 divided by 3 gets me 60. So I'm going to put equals 60. That is a whole number, so I'm guessing it's probably going to be my answer, but I'm still going to check the rest of my choices to be sure. C, 268, inverse operation of division, divided by 3. In my calculator, 268 divided by 3 equals 89.333333. So I'm going to round it to my hundredths, 89.33. This is not a whole number, so it can't be choice C. And I'm going to check one more, 211 divided by 3. Plug it in. I get 70.333333. I'm going to put it to my hundredths place, 70.33. Again, I have another decimal, so it can't be D. My only whole number in these choices is B, so that must be my answer. And 180 is a multiple of 3. All right, number 5. Which number below is a multiple? Multiples are, counting by the number, of 2. I like when I get a question about multiples of 2 because I know a trick for 2's. I know that all multiples of 2 end in, say it with me, 2, 4, 6, 8, or 0. So instead of having to go through all the calculator evidence like I did in number 4, I just have to look at the last digit and see if it's one of these numbers. So in 55, I'm going to underline the 5. I can tell that's not a multiple of 2 because it doesn't end in 2, 4, 6, 8, or 0. So I'm going to put a little X here. 176, I underline the 6. It looks like that is a multiple of 2, so I'm guessing that's my answer, but I still have to check all my choices. 193, I underline the 3. That's not a multiple of 2. 101, underline the 1. Again, not a multiple of 2, so my choice has to be B. It's really nice when we can use a trick to help us solve it quickly. Let's look at number 6 and see if we need a trick or a strategy. Which number below is a multiple? Multiples are, counting by the number, of 3. So for 3, I don't have a trick. I'm going to have to use my calculator strategy and think, how many times can I count by 3 to hopefully get, and then whatever the number is. So I'm going to check that. It's a missing multiplication problem, so I can check that with the inverse operation of division. So 61 divided by 3, I can put that in my calculator, and I get 20.33333. So I'm going to cut that off at the hundredths place, 20.33. That is a decimal, so it is not a whole number. It can't be choice A. Looking at choice B, 219, inverse operation of division, divide it by 3. In my calculator, 219 divided by 3, I get 73. That is a whole number, so that is likely my answer. So I'm going to put a star by that. Then I'm going to check C, do the inverse operation, divide by 3. 76 divided by 3 equals, I get 25.333. I'm going to put 25.33, cut it off at my hundredths there, another decimal, so it can't be choice C. Then finally, I need to check choice D, 110 divided by 3 equals, in my calculator, 110 divided by 3, I get 36.66. Again, another decimal, can't be D, so I know it has to be choice B, 219 is a multiple of 3. Moving on to number 7. Directions say, circle the numbers that are multiples are, counting by the number 6. Write your evidence above to prove it. So for 6s, I don't have a trick, so I have to use a calculator strategy. And I have to ask myself, how many times can I count by 6 to hopefully get, and then the number that I'm testing. And since it's an it's a missing multiplication problem, I can do the inverse operation of division. So I can take that number and divide it by 6 to get my evidence. So starting here with 34, I'm going to do the inverse operation of division. 34 divided by 6 equals 5.66666. I'm going to cut that off at the hundredths. 5.66. It is not a whole number, so I'm going to cross it out. 40. How many times can I count by 6 to hopefully get to 40? I can do the inverse operation. 40 divided by 6. I get 6.66666. I'm going to write it to the hundredths place. 6.66. Again, not a whole number. Cross it out. 72. How many times can I count by 6 to hopefully get 72? Inverse operation. Oops, turn it off there. 72 divided by 6 equals 12. I put 12 above my 72. That is a whole number, so 72 is a multiple of 6. Let's try it with 30. How many times can I count by 6 to hopefully get 30? Inverse operation, 30 divided by 6 equals 5. That's another whole number. I put my evidence at the top. I can circle 30. 30 is a multiple of 6. 18. How many times can I count by 6 to hopefully get to 18? Inverse operation, 18 divided by 6 equals 3. I've got a whole number. I can circle it. 18 is a multiple of 6. How many times can I count by 6 to hopefully get 36? Inverse operation to test it out. 36 divided by 6 equals 6. Put my 6 as evidence above it and circle it, because that is a multiple of 6. 51. How many times can I count by 6 to hopefully get to 51? Inverse operation, 51 divided by 6. I get 8.5. That is a decimal, not a whole number, so I cross it out. 54. How many times can I count by 6 to hopefully get to 54? 54 divided by 6, I get 9. That is a whole number, so I circle 54. It is a multiple of 6. Looking at the number 60, I say to myself, how many times can I count by 6 to hopefully get 60? Do the inverse operation of division to check it. 60 divided by 6 equals 10, and that makes sense because I know if my number ends in 0, it's a multiple of 10. So I put my whole number 10 and I circle it. Then finally, last one, 59. How many times can I count by 6 to hopefully get to 59? Plug it into my calculator. 59 divided by 6. I get 9.83333333. Cut it off at the hundreds place. I'm going to have to write beside it here. 9.83. A decimal, not a multiple of 6. You have made it to the last question, so you've made it to the secret word for this video. Your secret word is hot dog. There you go. All right, let's do the last one, number 8. Without doing any math work, explain how you know that 787 is not a multiple, multiples are, counting by the number, of 5. So I need to explain this to someone who has no idea what multiples are, so I need to be really clear in my answer. Now it's saying, how do I know it's not a multiple of 5? So let me think about my trick for multiples of 5. I know multiples of 5 can end in 5 or 0. If I look at 787 and I underline the last digit, it's a 7, which isn't a 5 or is not a 0, so I know it can't be a multiple of 5. So I'm going to write in a complete sentence, 787 is not a multiple of 5 because it ends in 7. Now that's correct, but I need to explain this to someone who has no clue what I'm talking about, and just saying that it ends in 7 doesn't really tell the whole rule. So I need to add a sentence explaining the rule to explain why this makes sense. So I'm going to write all multiples of 5 end in 5 or 0. So to get this problem full credit on your test, you have to say why it is or isn't a multiple because of what it ends in, and also say the rule, because it's not complete without both of those pieces of evidence. Nice job working on this today. We'll have our test tomorrow. I know you'll do great. If you're still here, I have a bonus secret for you, and if you have this at the end of your page, you can get an extra bonus for the secret word. If you write right under hot dog, write I, then a heart. Don't write the word love, it has to be a heart. Math, and then you have to put an exclamation point, and it has to look exactly like that. I heart math, because I know you love math and you're great at math and you're gonna do awesome. Have a great day. See you later.